All right, welcome back to Intro to Speech Recognition. So today is the second lecture of the fall semester, and we are continuing with our introduction to the Python programming language. Last week, I taught you how to use GitHub and how to upload and download your code from GitHub, and I taught you how to ask you to create a copy of the course repository, a fork of the course repository. This week, I'm going to continue some of the same things. So first of all, we'll use the command line to fetch and merge this week's release. And then I'm going to ask you to use GitHub Desktop to push the release. And the reason that we'll use GitHub Desktop instead of the command line is that on the command line, you have to authenticate yourself with GitHub. And it turns out that authenticating yourself with GitHub on the command line is very challenging, whereas using the desktop is quite straightforward. And then I'm going to introduce also how to use Jupyter Notebook to run Python. Python can also be run on the command line, but most text editors add extra indentation that makes Python fail. So if you edit your Python code in a normal text editor, it will usually fail. For that reason, it's best to use some kind of integrated development environment, and my favorite is the Jupyter Notebook. And then the main part of today's lecture, I want to introduce some key concepts in Python. I want to introduce two main data types, string and float. So basically strings and numbers. And I'll introduce the function isInstance, which can be used to tell what kind of object a variable is. Then I want to introduce one key syntax concept, if. The if statement allows you to decide whether or not to run a particular command, depending on whether or not some condition is met. And then I want to introduce the idea of defining a function and the idea of defining a module, a separate module. And these are the things that we'll use in order to allow us to do the homework for the rest of the course. So let me go ahead. First of all, let's use the command line to fetch and merge this week's release. So let me go ahead and minimize this and maximize this, I guess. We will, even when we're using Git Desktop, we will be using the command line to fetch and merge, because in order to fetch from the release remote, you will need to use the command line. So if you can open up a command line like this, and if you set up the remote last week the way that I asked you to do, then you should be able to go to your local code. You'll go to your local copy of the repository. So let's first look at it on GitHub. If we go to GitHub, github.com, and here I am under J. Hasegawa student. You see I have my student account, which should look very similar to your account, and I have the course account. This is my professor account. And in the professor account, you can see that now I have lecture 1 and lecture 2 posted. And so in order for you to get lecture 2 onto your own computer, you need to fetch the release. And so that's done by going to whatever is the directory where you have your copy on your laptop of the course repository. So in my case, I have it under KCGI Intro Speech Understanding. Let's make this even a little bit bigger so that it's easier to see. Okay. So if I type PWD, this is a Unix-like terminal. So it will tell me that this is Introduction to Speech Understanding. I'm not sure what the equivalent command is under Windows, but the git command is straightforward. Once you're in the Intro to Speech Understanding, you can type git fetch release. And if you defined the word release last week in the way that I showed you to do last week, then that will fetch the release. And then we can do git merge release main. And let's add this option. We need to add a comment. So merging release. So I'll add a comment, let's say merge release. And then after the comment, we can add this extra option, allow unrelated histories. This allows the fact that you edited your own code on the laptop doesn't change your ability to download lecture 2. So if there are unrelated histories, then those unrelated histories can be merged. So the full command is git merge release main, and then the -M option specifies a comment, and the -- allow unrelated histories allows it to merge unrelated histories. Mine is already up to date because I've already done this, but once you've done this, you should be able to type list and you find that in fact you have the lecture 2. If you change directory to lecture 2 and type list, you should see that there's a grade.py and a homework2.py. You should be able to more homework2.py and see the contents and see that this week we're going to write a function called arithmetic of x and y that does different things depending on whether x is a string or a float, depending on whether y is a string or a float. That's the entire point of this week's lecture. The entire point will be to write a function that uses an if statement to switch between different activities depending on whether the x and the y inputs are strings or floats. So let me go back to the slides. Now that we've used the terminal in order to get fetch the release and get merge the release, again, if this command doesn't work for you, then please go back and look at the slides from last week and look at the lecture video from last week. Let me remind you, the lecture video from last week is available under URL for lecture videos. If you go to the YouTube channel, you can see on the YouTube channel, we should be able to see the lecture from last week. That's not the lecture from last week. Let's see, can I find a playlist? Oh, here's the course introduction. Okay, and then the second lecture
KCGI Art.
Yes, here's the lecture from last week. Welcome to the fall semester 2025 of Introduction to Speech. So if you didn't see the lecture last week, or if you don't remember how to define the release in your GitHub, in your local GitHub copy, then please watch the video from last week and find out how to define the release. The command that you'll use is git remote, and you can check to see whether you have already done it by typing git remote -v. If you type git remote -v, you should have two different remotes, origin and release. This one actually has three, origin, release, and upstream, but the keys are origin should be your own copy. So you can see that in my case, origin points to my student account, and release should be my professor account. Your release should also point to exactly this URL. So if you want more information about those things, please check the slides in the video from last week. All right, now the next thing we need to be able to do is we need to be able to update your own copy on GitHub. If you can't, now we've updated your local copy on your laptop, but if you can't push that to your GitHub account, then I won't be able to see the work that you've done. And it turns out that there are several ways to push to GitHub. One is to just use the terminal, to use git push. And the problem is that that has authentication problems. Last week, we discovered that git push has trouble authenticating. And so instead, I recommend that you use the GitHub desktop. So let's open this URL. I recommend that you download the GitHub desktop. For me, you'll see that it says that I can download for Apple Silicon or I can download for the Intel chip for Mac OS. That's because it's automatically detected that I'm logging in from a Mac. If you're logging in from Windows, it should automatically tell that you're logging in from Windows. And please go ahead now and download the GitHub desktop. And when you've done it, you should be able to open it like this. So when you open the GitHub desktop, it will look something like this. The icon for it is this little dog icon that you see down in the corner of my screen. There's a little sort of, I don't know if it's a dog or a cat or what kind of animal it is, but it's some kind of animal in purple in front of a moon. And that icon shows that I have the GitHub desktop open. In this case, it shows that I've made some changes to a file in Lecture 2. And you should also see that it shows some changes. So when you download GitHub desktop and you have it open like this, then it should show that you've made some changes. So open it up and install it. When you open it, it will, when you first open it, so when you first download it and install it, it will ask, do you want to clone a new repository from the internet, or create a new repository on your local drive, or add an existing repository from your local drive? Let me maximize this so that you can see this in large format. So when you first download the GitHub desktop, the first screen that you'll see is, and when you click on it, the first screen you'll see is something like this. And you want to choose add an existing repository from your local drive. This assumes that last week you created the repository on your local drive, and now you want to add it to GitHub desktop. So find the directory that has your local copy. In my case, it's KCGI Intro Speech Understanding, and then click Add Repository. And what that will do is it will create a copy of the repository locally on your, it will give GitHub desktop access. You can see my cat wants to participate with the lecture today. And then once you've added that repository, you should see that there are some changes waiting to be pushed. And so now I can go back. In my case, when I opened it, I have some changes waiting to be pushed. And so I want to commit those and then push them to the origin. And as soon as I push them to the origin, that will make a copy back to my account on GitHub. So now if we go to my account on github.com, and we click on my student account, you should be able to see now that on your student account, you have Lecture 2 as well as Lecture 1. That's because Lecture 2 has been copied, right? It started out here. It started out on my professor account. From there, it was copied to your local laptop. And from your laptop, you copied it back to your student account on GitHub. And so now if you go to Lecture 2, you should see that Lecture 2 has just grade.py and homework2.py on GitHub. And you should see something like this. If you click on homework 2, it should define a function called arithmetic that returns 0. So please do those things. Please download GitHub Desktop, because that will be the easiest way on GitHub. And add your local copy of the repository from your laptop. And once you've done that, then push those changes back to github.com, so that if you go to your account on github.com, you can verify that Lecture 2 has been added to your account on github.com. So please take care of those things. If you are following along on a laptop, please feel free to do those things now. If you're not on a laptop now, then please make sure to do those things. You can do them during the office hours at the end of lecture today, or you can do them anytime between now and the time that the homework is due. Let me just wait for about 60 seconds to give people a chance to catch up if you wish. This is my cat. Her name is Kurumi. And you can see her tail, I think. All right. Let's go ahead then and start running Python. Now, there are many ways you can run Python. You can run it directly in the terminal. I can type Python, and now I'm running Python. I can do things like 5 plus 4, and it will give me the answer 9. Or if I don't want to run it in the terminal, I can run it in an integrated development environment like Visual Studio. If you have Visual Studio installed on your laptop, then you can use Python inside Visual Studio. Many of my students prefer Visual Studio. For myself, I prefer Jupyter Notebook. And so I'm going to show you how to install Jupyter Notebook and how to use it because I think, to me, it's the easiest way to run Python. If you installed Python from Anaconda, you may remember that I recommended installing the version of Python from Anaconda. You can just go to anaconda.com and you can get a free download. If you've done that, then you should be able to open an app called the Anaconda Navigator. In Macintosh, you just open the Spotlight search and type Anaconda Navigator. All right, that should work. Anaconda Navigator. Let me open it. Now it's opening. And when you open Anaconda Navigator, it will give you a menu of different Python tools, similar to the menu shown here. So Anaconda Toolbox, Anaconda AI, PyCharm, Qt Console, Spider is an IDE, Jupyter Lab, and Jupyter Notebook. And the version of the tool that we want is the one is Jupyter Notebook. And Anaconda Navigator is not starting for me. I don't know why. Let me try starting it this way and see if that starts. Here we go. Now you can see the green circle showing that Anaconda is starting up. All right. As I said, we don't need AI coding help right now, although you're welcome to use it if you want. As I said last week, you're allowed to use AI to help you code if you wish in this course. What we want is this one, the one called Jupyter Notebook. So I'm just going to launch Jupyter Notebook. What's really nice about Jupyter Notebook is that it just opens your browser. Whatever web browser you use, that web browser becomes your Python coding interface. And so you can code Python directly in your regular web browser. All right, so let me navigate to KCGI, Intro Speech Understanding, Lecture 2. And then once you reach KCGI, Intro Speech Understanding, Lecture 2, you probably won't already have a Python notebook. And so you'll want to create a new one. Type new, and you can choose console if you want, but I recommend just choosing notebook. This will create a new untitled notebook in the browser, and it will ask you which programming language you want to use. Choose Python, because that's the programming language we're going to use for this course. And now we have an interface. So for example, if you want help, you can type the command help and hit the triangle in order to run that command. In this case, it says help by itself is not a valid command. If I want interactive help, I should type help parentheses. If I want help on a particular object, I should type help and then the name of that object. So let me just type help parentheses and then hit the arrow, and it starts the interactive help. You can see this says, welcome to Python's help utility. If this is for your first time using Python, you should check out the tutorial. Enter the name of any module, keyword, or topic to get help. Each module also comes with a one-line summary. To quit, type Q. So let me type Q in order to quit the help. Let me go back to the slides for this week. The slides say that we should start Jupyter, click New Notebook, choose Python as the kernel, and then hit the triangle, the Go button, the triangle, right? Hit the triangle in order to run the commands in any window. Now that we have a window where we can run Python, let's actually run some Python. So the key things that I want to tell you about today are, first of all, two data types, string and float. Three data types, actually, string, float, and int. One piece of syntax, the if statement. How to define functions, and how to import code from a file, how to run a program from a file. So first of all, data types. Strings are stored in a data type called str. So let me define a few strings. Let me go to the Jupyter Notebook here, and let me say that A is equal to the string hello, and let me say that B is equal to the string hi there. Using double quotes here, and I'm using single quote here. A nice thing about Python is that you can use either double quote or single quote to define a string. So if I just define the string, let me print A and then let me print B, and when I run this code, it will print the string A, which is hello, and the string B, which is hi there. You can use either double quote or single quote. Whatever you use to start the string, you should also use to end the string. So if I start it with a single quote and end it with a double quote, that will be a syntax error. I have to start it with if I start it with a single quote, I have to also end it with a single quote. All right. The function that tells you what it is instance. So we can type is instance a str, and it will tell us true. A is a string. We can type is instance b str, and it will tell us true. B is a string. If I enter a number, 3.14, for example, it will tell me false. 3.14 is not a string. The other thing that you can type is you can actually enter the word type and ask for the type of A, and it will tell you what type of object it is. In this case, A is an object of type string. So we have these two functions, type and is instance, that will tell us what type of object any particular variable is. Is instance A, I need to ask, is it a string? So let me ask, is it a string? So we see that, let me print the type of A, and let me ask, is it a string? And the type of A is a string, and it's true that it is in fact a string. All right, so that's how we define strings. That's all there is to strings. If I want to print A and B next to each other, I can ask the print command to print A and B. And so it prints hello, hi there. Now let's do something funny. You can actually use arithmetic symbols to combine strings. The plus symbol, which normally means add, concatenates two strings. So I can type print A plus B, and it will just concatenate those two strings, one after the other. You see that it concatenated them without a space in between. Hello, hi there, with no space in between. The times symbol is used to print one string an integer number of times. So if I want to print hello, 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 I can print A times 3. Suppose that I want to print A with a space after it 3 times, then I need to create the string A plus space and then multiply that times 3. And so that creates the string hello plus a space and then multiplies that times 3. So you see that these arithmetic symbols, plus and times, mean sort of the obvious things with a string. They mean concatenate the string, and times means repeat that string this many times. Let's say I want to repeat it 23 times in a row. There's the word hello repeated 23 times in a row. All right, that's the first of today's data types. And the second of today's data types is the numerical data types. There are two of them actually, float and int. A number without quotation marks is either a float or an int. It's an integer if it has no decimal point, and it's a float if it has a decimal point. So let's type x is equal to 2, and let's type print x. Print x is, and then I'll print the value of x, and then we'll print the type of x is, and then we'll print the type of x. And you can see it says that the value of x is 2 and the type of x is int. So if I ask, is instance x int, it should say true. Yes, x is an integer. Let me ask, is x a float? And the answer is no, x is not a float. Now let me do something funny. Let me define the number z is equal to 3 point. And even though it's just the number 3, you would think it should be an integer. Putting the decimal point after it forces Python to interpret it as a floating point number. So here we have print z is, and we see that the value of z is 3.0. And because of the decimal point, it's a floating point number rather than an integer. So I can ask, is instance z int? And it will tell me false. Z is not an integer. I can ask, is instance z float? And it will tell me true. Z is a floating point number. We can also use floating point numbers to represent any arbitrary floating point number, like 1.12, for example. So here I'm going to say that y is 1.12 and the type of y is class float. If I ask, is y an example of int, it will tell me false. If I ask, is y an example of float, it will tell me true. All right. So now we have really three data types, strings, integers, and floating point numbers. Arithmetic for integers and floating point numbers works exactly like you would expect. So if I type x plus z, x is 2 and z is 3, so when I add them together, I should get 5. If I type x times z, 2 times 3 is 6. If I type x divided by z, let's see, x is 2 and z is 3, so this should be the number 2/3. 0.66666, that's 2/3. If I type x minus z, 2 minus 3 should be -1. And I can also type x raised to the power of z. This takes 2 and raises it to the third power. So 2 raised to the third power is 8.0. So the arithmetic operators actually perform regular, ordinary, everyday arithmetic when they're applied to integers and floating point numbers. In fact, Python is really useful as a desktop calculator. Often if I'm working on something on a terminal like this and I want to do some complicated calculation, like for example, I want to take $5, I'll just open a Python like this and type 0.05 times 4,000. And then I find that 5% of $4,000 is $200. And then I can quit again. It's often, once you get used to it, it's often faster to start Python in order to do calculations like that than it is to start your desktop calculator. Right? There's a desktop calculator app somewhere on the Apple, so I can try to open it. And once I open it, then I can type 0.05 times 4,000, and I get the same answer. Oops, no, I don't. I did something wrong. 0.05 times 4,000 equals $200. I get exactly the same answer from the desktop calculator, but it took me twice as long to get it. Desktop calculators are actually less efficient than just opening Python once you get used to Python. So it's useful to learn how to use floating point and arithmetic numbers in Python. It makes a great desktop calculator. 2 raised to the 3 is 8. Or you can also type in, you don't have to use variables, you can just type numbers. If I wanted to find 0.05 times 4,000, I can just type 0.05 times 4,000 and hit return, and I get the value. All right, those are our key data types for today. Today, I'm just going to tell you about string and float and int, and is instance and type. Now for our key syntax. Our key syntax idea is if. The if statement is if you have And it didn't print it worked because x is not equal to 3. X is equal to 2. So I have, if x equals 2, print it worked, and it prints it worked because x is actually equal to 2. The key things for syntax here, we need parentheses around the condition. So we have some condition if x equals 2. We need a colon at the end of the line. And then every following line needs to be indented by exactly 4 spaces. If you do this in Jupyter, it will happen automatically. Otherwise, if you're doing it in a text editor, you have to be very careful. The first line that's not indented ends the if statement. So if I print here this, the if statement is over, then when I run this code, it will say x is equal to 2. And then it will say the if statement is over. See, it says x equals 2, the if statement is over. If I ask whether x is equal to 3, x is not equal to 3. And so because this line has no indent at the beginning. So in Python, the part that's indented is inside the if statement. So now I have 2 lines inside the if statement, print x equals 3, and the if statement is still running. And so if I change that to asking whether x equals 2, then it will say x equals 2, and the if statement is still running, the if statement is over. Both of these lines are inside the if statement. This line is outside of it. Suppose that we want to have multiple conditions. We can have multiple conditions by using what's called else. So I can add a line else, print x is not equal to 3. And by adding 2 lines there, those lines will be printed when x is not equal to 3. If x is equal to 3, it runs these 2 commands. Otherwise, it runs these 2 commands. And so using if and then else allows us to do different functions depending on whether some condition is satisfied or not. All right, so we have this if statement, if x equals 3, print it worked. That's today's key syntax. Now let me talk about how to define functions. In any usable programming language, you want to define a function. Function definitions in Python are almost exactly like the if statement, but they use something called, they use a statement called def. So let me define a function double me. And what double me will do is it will return the value 2 times x. Notice that when I run this code, nothing happens. All that this code is defines a function called double me. Double me takes 1 argument, x. Notice the colon at the end. Notice that this line has 4 indents, and it returns that. So let me put an extra statement inside. Let me redefine double me to include the statement print running double me, and then it returns 2 times x. The return statement tells what the value should be after you run the function. If we now want to run the function, we can run it by, let's say we want to double 4, and we'll print now y is, and then I'll print the value of y. And it runs the function double me, it doubles 4, and now y is equal to 8. If I want to double 5, then I just run double me with the argument of 5. If I want to double 6, I just run double me with the value of 6. If I want to double 25, I just run double me with the value of 25, and so on. So I've defined a function called double me, and what this function does is it takes its argument and returns 2 times whatever its argument is. All right, so now we have strings and integers and floating point. We have if statements. We have functions. there's one more key concept I want to talk about today, and that is how to import code from a file. So let's import homework 2. You might remember that homework 2 is available to you here. You can open it and look at it. And if you open it and look at it, you can see that it defines a function called arithmetic. And in this function, there's a long string describing the content of the function. And then the value of the function is it just returns 0. So let me import homework 2. And then let me type help homework 2. And it will give me help on homework 2. Notice that help homework 2 returns help on the module. The name of the module is homework 2. It says this module defines one method called arithmetic. Notice where this string comes from. This entire string in the help file is the string that was defined at the very opening of this file called homework2.py. And then we have the function arithmetic. And arithmetic includes this string. You can see that that string is just the string that started the function arithmetic. So this module homework2 just defines one function. And if I say z is equal to homework2 dot arithmetic, and let's run arithmetic on 0, comma 0. Then when I set z equal to the value of 0, comma 0, now z is 0. In fact, that will be true no matter what I feed in because I've specified that the function arithmetic should always return a 0, right? In the definition for this function, the definition for this function now always returns a 0. Well, let's say I want it to return something else. Suppose I want it to return 2. I can change this to a 2 and then save it. Now it should return a 2 every time. But now there's one trick. If I just import homework 2 and then run arithmetic again. Let's see, let me copy all this. It still gives me a 0. This is kind of a weird bug. It's not actually a bug. What's happening here is that this import statement only runs the code the first time you call it. The second time you call it, it doesn't run the code. In order to get it to run the code again, we have to import something called the import lib. And then import lib reload homework 2. And once we do that, then all of our changes will be reloaded from homework 2. Now, if I print homework 2 arithmetic, it gives me the return value of 2. So now this change that I made to the function, I changed it so that it returns a 2. Let me change it so it returns 2000. Let me save this and then go back here and reload the homework. And then print homework 2 arithmetic of 5,000, 5,000. And now the value that it returns is always 2,000. All right, that's all we need for this week. We've learned that help homework 2 will give you something like this. Use Jupyter to open homework 2 for editing. We've edited it, and then we discovered that in order to get it to reload, we need to type import lib.reload. Here it is, import lib.reload. All right, so we have these 4 key concepts. Oh, we can also now import grade. Let's try that. Import grade, and that will run the grade.py. And you can see that it runs the grade.py and it gives me score of 0%. Let me just go ahead and open the grading function. This function grade specifies that when I run homework 2 with foo and bar, it should give the value foo bar. When I run homework 2 with foo and 3.12, it should give me the value foo, foo, foo. When I run it with 3.12 and foo, it should give me the value 3.12 foo as a string. And when I want to run it with the values 3.0 and 2.0, it should give me the value of 6.0 as an output. And here it's printed the score, which is the number of successes divided by the total number of results. In this case, I got 0 successes out of 4 results. It failed 4 times in a row, and so it gave me no success. And so finally, what I want to do is to actually do the homework. So let me show you now how to actually solve this week's homework and then how to upload it to your GitHub account so that I'll be able to see what you've done. Let's go back and open homework2.py and edit it. Now here's the instructions. Modify this code so that it performs one of 4 possible functions as specified in the following table. If x is a string and y is a string, it should return x plus y. So let me just write that. If is instance x string and is instance y string, then in that case, it should return x plus y. If x is a float and y is a string, it should return x converted into a string plus the string y. So let me write that. If is instance x float and is instance y string, then in that case, it should return x converted to a string concatenated with y. Similarly, if y is a float and x is a string, it should return x times the integer part of y. So if x is a string and y is a float, then in that case, it should return x times the integer part of y. And finally, if is instance x float and is instance y float, then it should return x times y. Now let's save that. Once we've saved it, we can go back to our notebook and let's try running homework2.arithmetic. Let's run it with the different possibilities. Let's try foo and bar. Oh, first of all, I want to reload it. So let me reload it. And then after I've reloaded it, let me run it with 2 strings, foo and bar. If I run it with 2 strings, foo and bar, it should return the value. Let me just delete this. It should return the value foo bar. So there it returned the value foo bar. If I run it with a string followed by an integer, followed by a floating point number, it should take this string and repeat it a number of times equal to the integer part of the floating point number. So if I take the string 3, it repeats it 3 times, foo, foo, foo. If I enter a floating point number followed by a string, it should return the floating point number converted to a string followed by the string. And if I enter 2 floating point numbers, let's say 3.0 and 2.0, it should multiply them together and return the value. So now it's doing everything that was specified in the doc string. And so now let me try re-importing grade and see if now I've got 100% on the grade. It ran 4 tests in 0.007 seconds. Okay, score was 100%. So now I've met all of the conditions to get 100% on my grade. Now the only thing I need to do is to publish it back to GitHub. If you go at this point back to GitHub, you will see that in your GitHub account, we still have return 0. So everything that we've changed locally on our laptop has not yet been published to GitHub. In order to publish it to GitHub, we need to edit the homework, and then we need to use GitHub Desktop. So let's open GitHub Desktop again. Look at that, it's showing all of the changes that I just made. So I want to commit those 2 files. It says I need a commit summary. So homework 2, and then I can print my summary. I did homework 2, and then commit those 2 files to main. And then I need to push them to the origin. Once you've committed it and pushed it, then it should show up in GitHub. Now let me reload my account on github.com. And we see that indeed, now my account on github.com shows, well, this is, let's see, let me make sure that I'm in my student account. Student account, J. Hasegawa student, intro speech understanding. Okay, so in that account, it now shows the changes on the homework. So at this point, the way that you get credit for the homework is to copy this URL and then go to the content for the course. Go to homework 2, and you'll see in homework 2 it says, please enter the URL of your homework2.py here. So go ahead and at that point write in the URL of your homework. And if you can write in the URL, I'll go ahead and give you 100. And if I check and make sure that it works, then I'll go ahead and give you 100 points for that. Let me see, is there anything else I need to tell you about? And copy the URL to Canvas so it can be graded. That's everything for today's class. Are there any questions? I'm going to go ahead and turn off the video.